Hey folks, coming at you with another update video. So I have been working on doing screen space based mouse picking. That's a mouthful. Try saying that 10 times fast. So what I've just implemented in my engine is a world space mouse picking implementation. So essentially, I cast a ray from my mouse, turn that into a world space origin and direction, and then see what geometry I've collided with in my engine. And that's all well and good, but it doesn't work very well for anything that has what I call deferred geometry. Anything that you don't know where exactly it's going to be until you're actually going through the rasterization pipeline, aka getting into your shaders and actually drawing to screen. So for geometry like that, using a screen space approach is definitely preferable. I'm sure you could finagle, recreate your shader math on the CPU side, but that would certainly be a bit of a mess. So what I mean by screen space based is just sort of rendering your scene a second time to a frame buffer texture, but instead of using a shader that would give me realistic shading like this, you'd actually give each object in your scene, and an object can be whatever you want it to be. In my case, I have an abstraction where something renderable is an object, so like a model chunk, or for example, or a label or text on the screen. And then instead of rendering that as it is, you would render it with a unique color ID. So every object gets a unique ID, and that color gets drawn into a texture of one of your frame buffers. And then you can sample that texture wherever you're clicking on that texture with your mouse, and you have a raycast. So hopefully that's a decent high-level explanation. Anyway, that's what I'm digging into. But the first part of that, um, and this is sort of tangentially related, is I wanted to be able to render transparent frame buffers because I'm implementing this with the intention of using it to have clickable buttons and things like that. So if I want to have clickable buttons, I actually need a framework for overlaying transparent GUIs onto my scene. And you might see this text here and go, well, don't you already have that? But text is different than just sort of a generic overlay. If I wanted to, for example, have a GUI that is separate from what's being fed out into this camera and handle that on its own, I couldn't do that unless I could overlay a transparent frame buffer. Right now, this text is just being rendered directly to this camera. So anyway, I hope that's a decent explanation. But long story short, what this allows me to do is, if we keep an eye on my bottom left here of the screen, is I'm going to take this camera and I'm going to stop rendering my world geometry. So what you'll have here, and I'll make this a little bit bigger, is we just have pretty much an empty frame buffer, except it is rendering this default text here. And that's because I'm sort of funneling the output from this, from a canvas. I don't know which item has the canvas on it, but I have a canvas that has this default text. And right now I'm just piping that into each of my cameras. But if I wanted to just pipe that into a specific camera and then overlay that, this would enable me to do that. So anyway, let's just show it. So what I have here is a new color widget. So Qt's color widget that I've been using in my engine is surprisingly buggy. It doesn't close properly, and it has weird behavior with signals, and it's also kind of ugly, and it also has a really clunky, unintuitive interface. It's just a mess, and what it doesn't even have is an alpha channel. So I found this widget online. If you just go on GitLab and look up Qt color widgets, I forget the name of the author, but it has a really great LGPL package. But I can turn down the opacity, and look here. We have our frame buffer rendering right on top of this other camera. So I think that's pretty powerful. I think that's a pretty neat feature to have if you want to have two whole different scenes you're rendering and then overlay one on top of the other with two different cameras. This enables you to do that, and I think that is pretty darn cool. And the way that I got this working was, first off, I need to take whatever color is being put out by this color widget and set that as the clear color of this frame buffer. And by clear color of the frame buffer, I just mean the color I used to clear my OpenGL context before rendering into the texture of that frame buffer. There's so much terminology with OpenGL and so much going on, it's hard to keep track of. But that's what I'm doing, so I'll leave this. That's fun. And I do want to show off a little bit in the code what I needed to do to the actual frame buffer itself. So if you did this in the first place, then you wouldn't have to make any adjustments. But let's assume you have some whole frame buffer pipeline set up. Frame buffer takes an internal texture format. And what I had as my internal format was RGB8, which means that I have 3 channels, each 8 bits, bits. And that's going to give me, that's going to give me my texture format. But that doesn't handle opacity, so I needed to change my format to add a 4th alpha channel. If I go into this enumerator here, and hopefully you can see that, I'm just sort of redefining OpenGL constants into my own enum. OpenGL is just all numbers, and nothing is object-oriented, and it's so hard to keep track of that I always try to abstract things out into my own API. So I think that's all I changed. I also have a floating point texture format that I use for high precision frame buffers. I added an alpha channel to that. And if you don't do that, what happens is when you render to the frame buffer, I believe the default behavior is for an RGB-based frame buffer is it's just going to set, I don't think it even has an alpha channel, but it treats it as if you have an alpha channel set equal to 1. So you're always going to have an opaque frame buffer. That's my understanding. I actually haven't tested that behavior. I figure, well, why try the wrong thing? Let me just add the alpha channel. So yeah, that was the 2 things I needed to do. I needed to add an alpha channel to my frame buffers. And you could always create more frame buffers that don't have an alpha channel. This is just sort of my global constants I've defined to set a default behavior. And then the second part of it was then just actually feeding that clear color to my frame buffers. And I guess you also do need to make sure that the quads that you're rendering those textures to for your cameras are rendered in the correct order, because if you render the transparent, if you render this guy before you render the rest of the geometry, then it's just going to show up as the clear color. And that's because it doesn't yet have any of this other geometry on the screen to blend with. So the order is important there. Transparent stuff you always render back to front. So that's fun. That's just a little, Anyway, I'm getting too into the weeds here, but hopefully you guys enjoyed the video. Just really talking over a lot of the stuff I've been doing, but I'm excited about it. I thought it'd be a lot more involved to get that working than it was. So it's always a nice surprise when things come a bit easier than you expect them to. Anyway, next steps are actually putting out the color ID information that I need to into a buffer, and then getting that over to my CPU. So I'll make another video about that, hopefully in a week or 2. Anyway, thanks a bunch for listening. Until next time.